Hello students, this is a homework to help you with questions such as the one you've got in front of you here, which is to do with the sine rule for area of a triangle, and the part B of this question, which you can't see at the moment. Part B is to the cosine rule. Okay, so sine rule for area and cosine rule for B. First things first, as always, we need to read the question carefully. So, diagram shows a parallelogram, EFGH. It tells you that E to F is 10.5 centimeters, and F to G is 19.2 centimeters, and it tells you the angle is 115 degrees. Question then says, work out the area of the parallelogram. Now, for those of you that don't know, a parallelogram is effectively a rectangle that has been pushed on its side. So as you can see here, this rectangle has been pushed over. And whilst it isn't relevant for this question, it's worth noting that these two lines, opposite sides, are parallel to each other, hence the word parallelogram. It's only a 2-mark question. And that's the first thing me as a maths teacher I notice, because actually there are a few different ways of working out the area. When you've got a parallelogram, one of the ways you can work out the area is to do the base multiplied by the vertical height, a lot like a rectangle. But be clear that that's vertical height and not the slant height, which I'd call L for length. So it's not the length that I want, it's the vertical height. Now I could do that, okay? It'd be complicated. I'd have to use trigonometry. I'd have to, form a right angle triangle here and work out the height of it. But actually, there is a easier, although I say easier with a bit of a smile on my face, because it's a much more complicated bit of maths, but it is an easier, quicker way of working out the area. And this is how. You're actually going to cut this parallelogram into 2 triangles. And those 2 triangles are identical. Okay, so I'll call it triangle 1 and triangle 2, but for all intents and purposes, it's triangle 1 and another triangle 1, really. And then you ask yourself, well, how do you work out the area of a triangle? So I'm just going to write area of triangle here. And I know that some of you will be looking at your computers at the moment, or your phones, or whatever you're watching this on, and thinking, well, sir, that's half base times height. And you'd be right. Base times height divided by 2, or half base times height, is one way. There is another formula, which I'm conscious that some of you may not know. But for all students who study higher tier maths, you should be familiar with one other formula for area of a triangle, which is half AB sine C. So what this formula, half AB sine C, is all about is finding the area of a triangle using 2 sides and the angle that's in between those 2 sides. So, in the example we have here, if I sort of ignore the fact this is an F, if I scribble that out and I call it capital C, and I call this side lowercase a and this side lowercase b, what you can see I've got is the 2 sides and the angle between those 2 sides. So what I'm going to do then is, at this stage, I'm going to grab a calculator, and I'm going to put the 3 numbers, 10.5, 19.2 and 115, in this formula. So in my calculator it will be something along the lines of 0.5 times 10.5 times 19.2 times sine 115. Okay? The reason I've written 0.5 is because that's what a half is as a decimal. So here I go, 0.5 times 10.5 times 19.2 times sine 115. And that's given me an answer of 91.35582.493. So that is the area of triangle number 1. Now, if you recall, earlier on I was saying to you, triangle number 1 is exactly the same as triangle number 2. So the parallelogram is made up of these 2 triangles. I've cut it in half. So effectively, I just have to multiply that answer by 2, and that will give me a total area, which is 182.7116499. The final step for this question is to round it correct to 3 significant figures. Now, I will remind you all of something that I often say to my Year 11 class, which is you should always write all the digits. Notice, I've written all the digits from my calculator there before I attempt to round it, in case I make a silly mistake rounding. So here I go with the rounding. 3 significant figures. This is 1, 2, 3. So I'll put a dotted line here. I'm looking at the 7, which is bigger than 5, which will make this round up to 183 centimeters squared. And that is the answer for this question. So the next part of the question down here, part B, says, work out the length of the diagonal EG of the parallelogram. Give your answer correct to 3 significant figures. So what I'm going to do, just to save us keep having to scroll up and scroll down, is I'm going to sketch the triangle we're talking about. So the triangle is EFG from the diagram above. So I'm just going to do a basic sketch of it here. So this is EFG. This angle was given as 115, this length was given as 19.2, and this length here was given as 10.5 centimeters. And the question is asking us to work out the length EG. So if I just put an X here, that's what they want us to find. They want to know how long that side is. And there is a rule which we can use for this. So if this was a right angled triangle, I would use standard, normal SOHCAHTOA to work this out. Sine, cos, or tan, label the triangle, etc., etc. However, in this case, it is not a right angled triangle. You can see that quite clearly. This is 115 degrees, which is more than 90, which means these two definitely have to be less than 90. So it's not right angled. So I have to use a different rule. Now, some of you will be familiar with this, some of you may not be, but the rule we're going to use here is called the cosine rule. And the cosine rule looks like this. It is a squared equals b squared plus c squared minus 2bc cos a. And that formula, usually you'll get given in the exam. Usually you'll be given this formula in the exam. Certainly this year you will. I'm talking about the examination year 21-22. But you may, it's worth knowing. Obviously, it's never a bad thing to memorize a formula. So, know the formula, know when you use it. Now, I can use this formula whenever I have two sides, B and C, and I have one angle that's in between those two sides. So let's look at this situation. And if I just take a different color pen, and I'm going to label this triangle, but with different labels. If I call this side here capital A, then that would make this lowercase a. If I call this side here capital B, then that would make this side here lowercase b. And if I make this side here capital C, that would make this side here lowercase c. So each corner, each angle has an opposite corresponding side. So capital A is opposite side A. Okay? Angle A, I should say, is opposite side A. And as you can see, I have got B. There's B there. I have got C. And I have got angle A. I have the 3 bits I need. So I can work out what A squared, and then just remember to square root it at the end, is going to be. So let's substitute in these numbers. I'm going to write A squared equals 10.5 squared plus 19.2 squared minus 2, and I'll use brackets here just so I don't get confused, times 10.5 times 19.2 times by the cos of 115. And as you can see, I'm running out of space here so slightly, but there it is. Okay. And really, you can put that straight into your calculator. Okay. Which I'm going to do now. I'm going to put that straight into my calculator as it's written there. There we go. So 10.5 squared plus 19.2 squared, take away 2 times 10.5 times 19.2 times cos 115. And we have an answer of a squared equals 649.2896831. And now obviously to get a on its own I need to do something to both sides, which is to square root both sides. And that's what I'm going to do finally. Square root that answer, giving me 25.4811633. Last bit of the question is to round it. So 3 significant figures, first, second, third. I'll put a little dotted line in here. 8 is bigger than 5, which means the 4 rounds up to become 25.5 centimeters. And that is the value of x, which is a in my example here. So here is a question now for you to try. Very similar, in fact, pretty much identical, except for the fact that the numbers are different. So please have a go at both of these. There's a part A to the question, and then there's a part B to the question. I want you to try both. Take a picture of your solution and upload this on class charts to complete your homework. Thank you very much, students.